Welcome back, students. Today I am going to tell you about the number line and the representation of a rational number on the number line. Okay, so before we start, you know the natural numbers. Natural numbers are 1, 2, 3, 4, so on up to infinity. Okay, natural numbers start from 1. All the counting numbers are natural numbers. So it starts with 1, 1, 2, 3, 4, 5, and so on up to infinity. That is why if I make the number line for natural numbers, it will start from 1, then 2, 3, 4, 5, 6, like that, and you will put an arrow over there which shows that it goes up to infinity. 1, 2, 3, 4, 5, 6 up to infinity. Now the next is whole numbers. Whole numbers, you know that whole numbers are 0, 1, 2, 3, 4, and so on up to infinity. Whole numbers start from 0, 0, 1, 2, 3, 4 up to infinity. So now if you draw the number line for whole numbers, it will start with 0. 0, 1, 2, 3, 4, 5, so on, and again there is an arrow which shows that it goes up to infinity. The next one is integers. Now you know that integers are all the natural numbers, their negatives, and along with 0. That means natural numbers, the integers can be -3, -2, -1, 0, 1, 2, 3, so on, going to infinity on either side. Okay, now what we do, you draw a line and put a 0 here, and then mark on either side. So it is 1, 2, 3, 4, so on, -1, -2, -3, -4, so on. Add an arrowhead on either side of the line, showing that in the positive side it is going to infinity, and on the negative side also it is going to infinity. So this is number line for integers. Now you know that rational numbers are also, they can be positive or negative, and 0 is also a rational number. So same number line we can use for rational numbers also. This the number line for integers, but the difference is 1 and 2, in between there cannot be any integer. We know that the 1 is an integer and the next integer is 2, and then 3 is the next integer, and so on. But between 1 and 2 we can have infinite number of rational numbers. So in case of rational numbers in the number line, we have to mark between 1 and 2 also. Clear? So now I'll tell you how to mark rational numbers on a number line. There is a question, mark 3 upon 7 on a rational number line. Now see, if you think that you will draw the number line for integers, and then between 0 and 1, because 3 upon 7 is less than 1 and more than 0, so between 0 and 1 you will divide it into 7 parts and then mark at the third place. So that will be very difficult, because you cannot divide a distance in 7 equal parts. So what we do, pay attention. This is the number line, and as our number is positive, so we need more distance on the positive side. So an arrowhead there. Similarly on this side, arrowhead there. Now see, mark this, as there is 7 in the denominator, you mark it as 1 upon 7, 2 upon 7, 3 upon 7, 4 upon 7, 5 upon 7, 6 upon 7. Now in place of 7 upon 7 you can write 1, and then 8 upon 7, and so on. And on the left hand side, minus 1 by 7, minus 2 by 7, minus 3 by 7, and so on. Clear? So now this is the number line. Now 0 and 1, it is automatically divided into 7 equal parts, and our mark is 3 upon 7, so you just put a dot on 3 upon 7, and that is your answer. So we have marked the rational number 3 by 7 on the number line. One more question, mark mark 7 upon 11 and minus 5 upon 11 on the same number line. Now there is a positive number and a negative number, and you have to mark both the numbers on the same number line. Clear? So first of all, you draw a number line like this. Now suppose this is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. On this side, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Like this. Now as 11 in the denominator, so here you will write 1 upon 11, 2 upon 11, 3 upon 11, 4 upon 11, 5 by 11, 6 by 11, 7 by 11, 8 by 11, 9 by 11, 10 by 11. Now 11 by 11 is nothing but 1, so you simply write down 1 here, and then you can write 12 by 11 like this. Okay, on this side also, minus 1 by 11, minus 2 by 11, minus 3 by 11, minus 4 by 11, minus 5 by 11, minus 6 by 11, and so on. Now you see the first number is 7 by 11. 7 by 11 means here, so you put a dot here. This is 7 by 11, and the other number is minus 5 by 11, so minus 5 by 11 is here, so you put a dot here. Okay, So this is 7 upon 11 and this is minus 5 by 11. These are the answers, 7 by 11 and minus 5 by 11. Clear? Now the next question. Mark 2 whole 3 by 4 on the number line. Now on a rational number line you have to mark 2 whole 3 by 4. You have to mark 2 whole 3 by 4 on the number line. Now first of all, what will you do? You will change this mixed fraction into improper fraction. Means 2 whole 3 by 4 means 11 by 4. Okay. Now draw the number line. As it is a positive number, so we need more distance on the positive side. Now, as there is a 4 in the denominator, so your first one will be 1 upon 4, then 2 by 4, then 3 by 4. Then instead of 4 by 4, you write down 1. Then 5 by 4, 6 by 4, 7 by 4. Instead of 8 by 4, you write down 2. Then 9 by 4, 10 by 4, 11 by 4. Instead of 12 by 4, you write down 3. And then 13 by 4 and so on. And on the left hand side or on the negative side, minus 1 upon 4, minus 2 upon 4, minus 3 upon 4 and so on. Now your number is 11 upon 4. So here it is 11 upon 4. So you just put a dot here on 11 upon 4. A dot on 11 upon 4. Clear? Now mark minus 3 whole 2 by 3 on the number line. Mark minus 3 whole 2 by 3 on the number line. So as I did in the previous question, first of all you convert it into improper fraction. So minus 3 whole 2 by 3 will be equal to minus 11 upon 3. Okay. Now draw a line. But this time we need a negative, we have to plot a negative number, so we need more distance on the negative side. like this. Now as there is a 3 in the denominator, so if this will be 1 upon 3, 2 upon 3, in place of 3 upon 3 you write down 1, then 4 by 3, then 5 by 3, then in place of 6 by 3 you write down 2, and then 7 by 3. On the negative side, minus 1 upon 3, minus 2 upon 3. Now instead of minus 3 upon 3 you write down minus 1, minus 4 upon 3, minus 5 upon 3. Instead of minus 6 upon 3 you write down minus 2, then minus 7 upon 3, minus 8 upon 3, and now instead of minus 9 upon 3 you write down minus 3. Clear? Then minus 10 by 3, minus 11 by 3. Instead of minus 12 by 3 you write down minus 4, minus 13 by 3, and so on. Now the number that we have to plot is minus 11 by 3. Here it is minus 11 by 3. So simply put a dot on minus 11 by 3. You put a dot on minus 11 upon 3. Clear? Now another question, mark 4 by 9 on the number line. Mark 4 upon 9 on the number line. So first of all, you draw a line, straight line. Now as I told you, the number is positive, so we need more space on the positive side. So mark 0 here, and then using the ruler make distances at markings at equal distances. Use ruler for that on the other side also. Now as there is a 9 in the denominator, so you write down here 1 upon 9, 2 upon 9, 3 upon 9, 4 upon 9, 5 by 9, 6 by 9, 7 by 9, 8 by 9. Now instead of 9 by 9 you write down 1, 10 by 9, 11 by 9, 12 by 9, and so on. That arrow shows that it is extended up to infinity. Now on the negative side, minus 1 by 9, minus 2 by 9, minus 3 by 9, minus 4 by 9, and there is an arrowhead on the left hand side also, means on the negative side also it is going to infinity. Clear? Now what we do, our number is 4 by 9. So at 4 by 9 you have to make this dot. At 4 by 9 you will make this dot. Clear? Now this is your answer. Okay? One more question. Mark 2 by 3 and minus 4 upon 5 on the same number line. So you can see now they have given two numbers, one number is positive, the other number is negative, and you have to plot both the numbers or mark both the numbers on a number line. On the same number line, you have to mark the two numbers. But the difference in this question is, you can see the denominator of the two numbers are different. In one number, the denominator is 3. In the other number, the denominator is 5. So first of all, we have to make the denominators same. So find out the LCM of 3 and 5. LCM of 3 and 5 is equal to 15. You know that. So 2 by 3 is equal to, you multiply both numerator and denominator by 5, so it is 10 by 15. And minus 4 by 5, you multiply both the numerator and denominator by 3, so it is minus 12 by 15. Now you see, this 2 by 3 is actually 10 by 15, and minus 4 by 5 is actually minus 12 by 15. Now the denominators are same, although the fractions are different, but we have made the denominators same in both the cases. Now you draw a straight line, and see, on the positive side we need 10 markings, on the negative side we need 12 markings, means in all 22 markings, so you make 25 markings. So take your scale accordingly so that 25 markings can be made on this number line. So you can start from here, make an arrowhead here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. That is sufficient. Now you see, we need minus 12, we'll start from minus 13. So minus 13 upon 15, minus 12 upon 15, minus 11 upon 15, minus 10 upon 15, minus 9 upon 15, minus 8 upon 15, minus 7 upon 15, minus 6 upon 15, minus 5 by 15, minus 4 by 15, minus 3 by 15, minus 2 by 15, minus 1 by 15 and 0. And then 1 by 15, 2 by 15, 3 by 15, 4 by 15, 5 by 15, 6 by 15, 7 by 15, 8 by 15, 9 by 15, 10 by 15, 11 by 15, like this. Okay, so all the distances between the markings are same. So now you see, the positive number was 10 by 15, so 10 by 15 is here, so you mark a dot here, and the negative one was minus 12 by 15, so minus 12 by 15 is here, so you mark a dot here. Clear? So this is 10 by 15 and this is minus 12 by 15. So we have marked 10 by 15 and minus 12 upon 15 on the number line. So this is the process by which we can mark any number or any rational number on the number line for rational numbers. Clear? So in the next lecture I'll tell you about how to find a number of rational numbers between two given rational numbers. Sometimes two rational numbers are given and they say find 3 rational numbers or 5 rational numbers or 10 rational numbers between given two rational numbers. That I will tell you in the next class. Okay.